my dear viewers, in this video we are going to talk about adding vectors using graphical method. In this video on the graphical method there are two sub-methods and I will be discussing them today, and the examples of those two methods will be discussed tomorrow. So do not forget to watch tomorrow's episode also. And also this video is brought to you by Learning Mind Zone and Funfetti Kitchen. Well, my dear viewers, as I said before, in today's video we are going to talk about the addition of vectors. And addition of vectors can be done graphically and numerically in both methods. So today we are going to talk about addition of vectors graphically. So under this graphical topic, I am going to discuss about two different methods, the parallelogram method and the tip to tail method. So within 10 to 15 minutes, let us go and excel in the topic of addition of vectors. So first, let us go through the parallelogram method. Okay, now we have two vectors here, vector A and vector B. So now we are going to find the we are going to add the vector and find the resultant vector of these two vectors A and B. So as a start, it's a good idea to put the two tails of the vector in one location. I mean, to construct a common point where the two tails of the two vectors meet. For that purpose, I construct two lines, one parallel to B and one parallel to A. So the one line that is parallel to B starts from the tail of A, and the line which is parallel to A starts from the tail of B. Imagine that this is a parallelogram. So the intersection point here, this is known as R or the resultant. Always the sum of two vectors is the resultant. The intersection point of the construction is the sum of two vectors. Now, if you construct a diagonal from the intersection point of the two major vectors tail and to the imaginary line's intersection point, that diagonal represents the sum of A and B vector in a graphical method. So this diagonal here, now we call when we connect two edges from the inside, we call it as a diagonal. So if you consider this diagonal is the resultant or the sum of both the vectors A and B. You can denote them as follows: R equals to A plus B. See, I didn't just add the magnitude of A and B because the direction is very important. So if you want the exact measurements, you can have a ruler and measure this diagonal. Then you will get the sum of the A and B vector. So the next method to add two vectors graphically is the tip to tail method. To explain the tip to tail method, I take the same diagram. So we have two vectors A and B, and we are supposed to add them and find the resultant. Notice that both tails are together. So we are going to move one vector to the tip to the another vectors, or simply by not changing the magnitude or the direction to the another vector's point. So earlier, as you know, I have mentioned in the introduction to vectors, you can move one vector to another position without changing the magnitude or the direction. So I can transfer this particular vector to this point, and this would be my new A. So now, as you did in the parallelogram method, now if you draw an imaginary line from the tail of the A and B intersection point to the tip of A, that would be the resultant, or simply the sum of A and B vectors. So you might wonder, what if I had three vectors drawn on the same plane? Pause for a moment and think, and leave your answers in the comment box below. So this is also simple. Now in the tip to tail method, what we do is we move the positions of one vector to another position. So first we move the position of B, from the tail of the intersection point to the tip of A. We are going to construct a new B here, and then we have this C. So what do we do with the C? We construct C from the tail of the intersection point to the tip of the new B. But do not forget, we are going to construct all these lines parallel to each other. I mean parallel to the original vector. So the rest is simple. What are you going to do next is, from the intersection point of A and B vectors here, you are going to, simply from the intersection point of all three vectors, you are going to draw an imaginary line up to the tip of C, the new C, and there you are, the resultant of the ABC vector. So in my next video, I am going to discuss the examples related to the addition of vectors graphically using both parallelogram and the tip-to-tape method. So until we meet in our next video, with me Brainiac signing off. And if you liked, and also I forgot to mention that if you like this video, please give a thumbs up and do not forget to subscribe to the Brainiac. And also do not forget to subscribe to our sponsors, Funfetti Kitchen and Learning Mindset. Their channels are given in the featured channel list on my channel tab. So thank you for watching the video again, and bye for now.